Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you're just going to have x minus 8 times x minus 8, which you can also write as x minus 8 squared. For the math knowledge question, we want to find the slope for a parallel line. So the first thing we have to do is solve for y. So 5y equals negative 6x plus 7, and then divide by 5. And our slope would be right here, negative 6 over 5. So that would be your answer there. Okay, so we are looking at lesson 31 today. We're going to look at symmetry, reflections, and translations. This is somewhat of a geometry review concept, but instead of graphing pictures like we did in geometry, we're going to more be looking at equations, and not graphs of shapes, but graphs of functions. So it's a little bit different from what you're probably thinking of symmetry, reflections, and translations from geometry. But hopefully you understand how they work after this lesson. So going back to reflections, mirror images, you just reflect it across the line of reflection, which is M. So A is going to be 5 away, B is going to be 5 away on the other side. We dealt with symmetry before. Parabolas are symmetric about the line of symmetry. This point is the same distance away as this point from your line of symmetry. So that's the most common one that's going to be symmetric, is going to be a parabola. M is the point of symmetry here because it's the point that is equidistant from A and B. So for your graphs, if you replace x with negative x and it results in an equivalent equation, that means it's going to be symmetric about the y-axis. And then if you replace y with negative y and it gives you the same equation, then that means it's symmetric about the x-axis. So if you plug in negative x and it doesn't change your equation, then that's symmetric about the y-axis. And if you plug in negative y and it doesn't change your equation, then it's symmetric about the x-axis. For any equation that is in x and y, if it's symmetric about the x-axis and also symmetric about the y-axis, then it's going to be symmetric about the origin. So an example of that would be a circle. If it's symmetric about the x and the y-axis, then it's also symmetric about the origin. So that's the most common one that's going to be symmetric about the origin. Okay, if you leave your y value unchanged and you replace your x with negative x, then it's going to become a reflection across the y-axis. So they've changed our x's to negative x. So this one still stayed as x squared, but it's going to become minus 8x and then plus 16. So it's going to flip it across the y-axis. And then if we leave the x values unchanged and we change the y values, then it's going to reflect it across the x-axis. So if you change your x's, it's going to reflect it across the y, and if you change your y, it's going to reflect it across the x. It's the opposite axis that's going to be changed. Now, there is a big difference between the notion of f of negative x and negative f of x. This means everywhere you have an x, that we would make it negative x squared and then negative x. But over here, that same equation would go to negative x squared plus 3x minus 4. So this one would be x squared minus 3x minus 4, and this one would be negative x squared minus 3x plus 4. So it's a big difference between having the negative with the x and the negative on the outside. So for translations, basically, if you put a number in with your x, it's going to switch the direction that it's going to go. So if we do x plus 8, that's actually going to push it to the left 8. And if we do x minus 8, that's going to push it to the right by 8. It's the opposite of what you would think. Same thing is what this says. It said the x plus h and then the x minus h. So if you put it inside with your parentheses, it's going to do the opposite of what you would think it would do. And then if you want to push it up or down, if you add from 2 to get to 7, that's adding 5. It's just going to shift it up by 5. And then if you subtract 5, so 2 minus 5 is negative 3, it's just going to shift it down by 5. So when I'm shifting it up and down, what you would think would happen, if it's a positive, then it's going to go up, and if it's a negative, it's going to go down. That's exactly what you would expect to happen, probably. So that's what that says. So now we're going to get to the examples. So again, it's the same concept as what we did in geometry, but it's a completely different question. They tell us this is the graph of the square root of x, and we want to know what is the graph here. Well, it was reflected across the y-axis. So that means that our x values were changed. And so that's just going to be the y equals square root of negative x. So that would be the equation of this new graph. Your x values are changed because it went across the y-axis. And that's the only difference in the equations. Okay, we're going to look at another one. They give us y equals the square root of x. Now on this one, two things happen. It gets flipped down and shifted. So let's deal with the flip down part first. To make it flip down, that means that it's going to go across the x-axis. So the y value is going to become negative. Okay, and then it was shifted to the left by 3. So our x value is going to be x plus 3. And then to solve for y, just divide by a negative. So y equals negative square root of x plus 3. And that would be the equation here. And you can plug in numbers if you want to check and see if it makes this shape. So if you plugged in 0, you would get negative 3. If you plugged in negative 2, you would get negative 1. If you plugged in 1, you would get negative 2. And so you can tell that that is basically what it's supposed to be doing. Okay, so we're going to look at one more. And this is dealing with the graph of y equals 1 over x. So this is a reciprocal function. So we did reciprocals a few lessons back. So first off, we're going to graph y equals x. And so that's just a line. And then everywhere it crosses the x-axis, you put a vertical asymptote. And then at 1 and negative 1, you put dots. And so then there's the graph as it approaches your asymptote and your your x-axis. And then it says we translated 3 units to the left and 4 units down. So when it goes to the left or to the right, that is in with the x. So it's going to be y equals 1 over x, not minus 3, but plus 3. And then when it's down, it goes at the end. And so minus 4. And so what's going to happen? I'm going to do this one in red. Our vertical asymptote is going to be shifted 3 to the left. And then our x-axis is going to be 4 down. So 1, 2, 3, 4. And then the same graph is going to happen. So the red would be the graph of the new equation. So that's how that one would work. Okay, so now we're going to look at our homework. You do get to omit number 10, and you need to start studying for your unit circle quiz that's going to happen with lesson 32. That's the very next lesson. You're going to have 10 minutes to do it. It's 48 points. You're either typically going to make a 40 or above, or you're going to make like a 10. It's up to you. You need to be practicing it. So if y'all want to go get your unit circles, dry erase markers, and practice doing that in class, or if you want to do it on paper, I don't care, but you have to practice it. You got to make sure that you can get all of your positive and negatives correct as well. So make sure to study for that and to do your homework.